In this tutorial, we explain the concepts of limits. Limit is the first lesson in calculus, and it is study of the behavior of the function in a neighborhood of a point. Using limits, we define the instantaneous rate of change, which is the base for differential calculus. When we say x approaches a from the right side, that means x is getting closer and closer to a, and it is larger than a. This is denoted by this notation: x arrow a little plus on top of a, and that means x moves towards a from the bigger side. Similarly, when x approaches a from the left side, which is denoted by this notation, x is getting closer and closer to a, and it is smaller than a. When we say limit of f of x as x approaches a is L, that means f of x can be as close as we want to L for all sufficiently close values of x to a from the right side without actually letting x be a. Similarly, we define limit of f of x as x approaches a from the left side. The limit of f of x as x approaches a exists if and only if both the left and the right side limit of f of x as x approaches a exist and they are equal to each other. For example, the function here when x approaches 1 from the right side, limit of f of x is 2, and if x approaches 1 from the left side, limit of f of x is 1. Both the right and the left side limit as x approaches 1 exist, but they are not the same. Therefore, limit of f of x as x approaches 1 does not exist. In this example, whether x approaches 4 from the right side or the left side, f of x approaches 8. When x is around 4, f of x is around 8. Therefore, the limit of f of x as x approaches 4 is 8. In this section, we calculate a couple of limits using the table of values. Let's find the limit of 2x as x approaches 3. Our expectation is when x is getting close to 3, 2x is getting close to 6. We evaluated the values of the function at 3.1, 3.01, 3.001 from the right side. As x approaches 3, f of x approaches 6. Similarly from the left side. Therefore, the limit of 2x as x approaches 3 is 6. For f of x equals x2 minus 1, we are looking for limit of f of x as x approaches 3 from right side. We evaluated the values of the function at 3.1, 3.01, and 3.001, and we'll see as x approaches 3 from the right side, f of x approaches 8 Therefore, the limit of f of x as x approaches 3 from the right side is 8. F of x equals 1 when x is greater than 1 and negative 1 when x is less than 1. If we evaluate the values of the function at 1.1, 1.01, and 1.001, all three of them are 1. That means the limit of f of x as x approaches 1 from right side is 1. Similarly, the limit of f of x as x approaches 1 from the left side is negative 1. Since the right side and the left side limit of f of x as x approaches 1 are not the same, limit of f of x as x approaches 1 does not exist. Last example, f of x equals 4 as x approaches when x is not 3 and 1 when x is 3. Obviously, f of a when a is not 3 is 4. Therefore, both the right and the left side limit of f of x as x approaches 3 is 4, which means limit of f of x as x approaches 3 is 4. In this section, we are going to talk about properties of limit. Limit of a constant function as x approaches a is that constant. For example, limit of 20 as x approaches 1 is 20. Limit of x as x approaches a is a. Limit of x as x approaches 5 is 5. Limit of addition of two functions as x approaches a is addition of the limits as x approaches a. Similarly, limit of subtraction of two functions as x approaches a is subtraction of limits. For example, limit of x plus x2 as x approaches 4 is limit of x as x approaches 4 plus limit of x2 as x approaches 4. Or limit of x minus x2 as x approaches 2 is limit of x approaches 2 minus limit of x2 as x approaches 2. Limit of a constant times a function as x approaches a is constant times limit of the function as x approaches a. For example, limit of 4x2 as x approaches 1 is 4 times limit of x2 as x approaches 1. Limit of multiplication of two functions as x approaches a is a limit of first function as x approaches a times limit of the second function as x approaches a. Limit of division of two functions is limit of numerator divided by limit of the denominator, provided that the limit of the denominator is not 0. For example, limit of 2x plus 1 times x2 plus 1 as x approaches 1 is limit of the first function as x approaches 1, limit of 2x plus 1 as x approaches 1, as x approaches 3 in this, times limit of x2 plus 1 as x approaches 3. Or limit of x plus 4 divided by 2x as x approaches 10 is limit of x plus 4 as x approaches 10 divided by limit of 2x as x approaches 10. This would be limit of x as x approaches 10 plus limit of 4 as x approaches 10, which is 10 plus 4, divided by 2 times limit of x as x approaches 10, which is 20. Limit of f of x to the power of n as x approaches a is limit of f of x to the power of n as x approaches a. We find the limit first, then to the power of n. For example, limit of x plus 2 to the power of 3 is the same as limit of x plus 2 to the power of 3. Limit of x plus 2 as x approaches 4 is 6. Therefore, this limit would be 6 to the power of 3. And limit of nth root of f of x as x approaches a is nth root of limit of f of x as x approaches a. If the nth root of the limit exists, for example, limit of the fifth root of x2 minus 4 as x approaches 2 is the same as fifth root of limit of x2 minus 4 as x approaches 2. Limit of x2 minus 4 is limit of x2 minus limit of 4 as x approaches 2. Limit of x2 as x approaches 2 is limit of x as x approaches 2 times limit of x as x approaches 2, which is 2 times 2, 4, minus limit of 4. 4 is a constant. When x approaches 2, limit of 4 is 4. Therefore, this limit is 0. Thank you.